Okay, problem 29. So in this problem we have a function which is 0 if x is rational and x if x is irrational, and g of x is 0 if x is irrational and x if x is rational. So what does f of x look like? So let's just try to figure out what the curves will look like. So let's say if this is your Cartesian plane, okay, so this is your Cartesian plane, and the function f of x equals to x if x is what was it, irrational. Okay, so for irrational values this function will look like this. So there will be lots of dots along the y equals to x line. So there will be gaps whenever x is rational, and there will be it will be a line. So in reality it will look like a line, but it will have infinite amount of holes in any interval. Okay, you take any interval, you find infinite amount of holes. So that's the property of density. And then you have g of x, which is x if x is rational. So what this will look like is it will be filling these holes. Okay, so it will be filling these holes. Okay, so if somebody asks you f of x plus g of x, it will be just the y equals to x line. So that is definitely 1 to 1, but that's not what they have asked us. They have asked us f of x minus g of x. So they have asked us f of x minus g of x. So f of x minus g of x would be x if x is irrational, and minus x if x is rational. Now is this thing 1 to 1 or not? So for rational values, the idea is that for is it surjective, is it 1 to 1 and on 2? Okay, so that's the question. So for any x, is every x being mapped to something unique? Okay, so the question is, if f of, so let me call this function as h of x. Okay, so the question is if h of x1 equals to h of x2 is true. Okay, so does this imply that x1 should be equal to x2? Okay, so this is your property 1. Now is this thing true or not? So if h of x1 is equals to h of x2, then if they are both rationals, then you are basically saying x1 equals to x2. Okay, so x1 equals to x2. If they are both irrational, then you are saying minus x1 is equals to minus x2. So irrespective of if x1 is same or not, then this thing is true. So so if h of x1 is equals to h of x2, this implies that x1 is equals to x2. On the other hand, if x1 is equals to x2, then this implies that so this thing says that no 2 points will be mapped to a singular point. So this implies that the function h is 1 to 1. Now we need to prove the onto part. So is there any point which is not being mapped? Okay, so so this thing is obviously not true, because for all points, for all r, for all x belonging to r, there exists or rather for every y belonging to r, there exists x belonging to r such that f of x is equals to y. Okay, so this is the second theorem. This is also true. Okay, this is true because you give me any x. Okay, so if y is rational, then the x that I am looking for is going to be minus y, and if y is irrational, then the x that I am looking for is going to be y itself. Okay, so that's why this thing is also true, which implies, so this theorem will imply that this part will imply that h is onto. So h is both one to one and onto. So hence my function h of x is surjective. Okay.